Hello. Okay, I'm Syrus, and today we will be talking about how to compile Python to WebAssembly. But before I even start, I would like to thank Sergi and all the people on the backstage for the awesome work that they are doing, and also for every one of you. Like, it's been super welcoming coming here and seeing like all of you, chatting with all of you, and so on. Thank you. So today we are going to see how to compile Python to WebAssembly. And the most important thing is not just like what we did technically to achieve this. It's also how we got here. So let me start from the beginning. Who am I? This is me when I was 6, 7 years old. I've always been like super curious, loved playing with Legos and so on. Don't worry, my own part, like talking about myself, will be like super quick. A few years after, I created a website for watching TV online and listening to radio online that became very popular, pre-YouTube, more than 300,000 people visiting each month, which was pretty nice. And a little bit after, I moved to Silicon Valley, and Facebook was working on one framework called GraphQL. And I fell in love with it. I thought it was great. And I was a very Python guy, so I created the first framework for using GraphQL in Python called Graphene. This helped me kind of like to understand a lot of things about the framework and so on. But there was one issue, which was I never raised money for a company. I wanted to create a company about this, a business about this. And I was competing against other startups that raised like tons of millions of dollars. And they were basically like all trying to do frameworks or ecosystems for GraphQL. And me, as a solo founder, I wanted to make my framework available in as many languages as possible, with just one implementation. So I wanted to make it universal. Probably like by then, it was not obvious that the solution for this was WebAssembly. But yeah, after like a lot of research in 2018, I realized that there was a new technology that had a lot of possibilities for achieving what I wanted to achieve, which was WebAssembly. Again, by then, it was not evident that WebAssembly was going to become a big thing. So the first question is, can I compile Graphene, which is a Python library, to WebAssembly? And basically, like, WebAssembly could help me on the quest of having a universal GraphQL library that will work anywhere. Like, no matter the language where it's written like or used, could be Python, could be Go, could be Rust, could be JavaScript. And this idea is super powerful. So I wanted to research on that idea. And that's more or less how I came into Wasmer. It was a nice ride. Obviously, I realized that the idea of creating a business on the WebAssembly space was a little bit bigger, or maybe much bigger, than creating a business on the GraphQL arena. So I started Wasmer. This is around like 2018 as well. And when I started using or trying to use WebAssembly, I realized that on my quest of trying to have a universal GraphQL library, actually it was very challenging being able to use WebAssembly from basically like anywhere, from other languages, standalone, and so on. So long story short, I started Wasmer, and we created a registry. We created like many different products inside of Wasmer. And one of the products, because I'm still a Python guy, and by then I was the only one like starting basically the backend, the runtime, and everything. And I was used to Django. I wanted to continue using Django. So we use Django for backend. We use Graphene because, I don't know, I created it. I was very familiar with it. And basically, like right now, our backend is actually running on Google Cloud. It's awesome, but it's very expensive. So a few years ago, we started working on Wasmer Edge, which is, if you know like what Heroku is, it's a Heroku basically like completely focused on the WebAssembly spectrum. And what are the advantages is that mainly you can get like super fast speeds, and you can also like pay very cheap prices for it, which is great. Our hope is going from like $1,000 for cloud bill to more or less $50 spending per month, which is quite nice. So the question arises, could we run Wasmer Python backend performantly on Wasmer Edge? So we not only want to run it on the clouds, we want to be able to have a package that runs still on Wasmer Edge. So it's not important only being able to run it, but being able to run it performantly. So the obvious way is just, let's use the CPython interpreter in WebAssembly. When I started, Wasmer trying to compile Python into WebAssembly was one of the first things that we achieved. Actually, that was a pretty big deal. We were the first ones to compile Python to Wasm, and then to compile it to Wasm, but that's kind of like for a little bit longer story. But here's the reality. The performance sucked. It was not great. It was not as good as running Python, like basically natively, using like normal Docker images and so on. And yeah, basically, like while this is good, it gets things going, it's not as fast as it can get, which means it will be more expensive for us to run it than we would like. So we start thinking on how we can improve the performance of running our Python backend in Wasmer Edge. Not just Wasmer Edge, Wasmer could be WebAssembly. What I'm talking today is actually not about running Python performance in Wasmer Edge, it's any WebAssembly. So if you use any other runtime, you can literally use the same strategy. So how we can make Python go super fast in WebAssembly? There are 3 strategies that we can use. First one is we will use a Python subset. More or less, it's kind of like a language very similar to Python, but it's not Python. And that Python subset can be compiled into very performant code. That's one strategy. Other strategy is using a JIT inside of Python. And the last strategy is using static analysis, basically like analyzing the Python code, trying to see all the typings that we are using, and try to use that to optimize code. So we are going to see in the next slides how each of these strategies worked out. So basically, you get the learnings that we got while doing this. So let's start with the Python subset. Basically, like there are like multiple strategies. I just list 3, but there are like probably like 5 to 10 ways of doing this. So one of them that was actually like launched in Hacker News 1.5 years ago was called Codon. Other one is Python, and the other one is Cython. Cython is probably the most popular. Again, it's not the same language as Python. There are some big differences. So what are the pros is it can be compiled to really performant code, but the issue is it doesn't support the full Python syntax. So if you're familiar with the JavaScript ecosystem, this strategy is very similar to basically like using AssemblyScript. AssemblyScript is not the same as JavaScript, but kind of like you can use a TypeScript subset to be able to compile into WebAssembly. So let's start with Python. How Python works is you have like a subset of Python called restricted Python. This is where the R comes from. And basically, like you define your Python code. You call like Python hello world.py, I mean, whatever file you're using. This will generate under the hood like a C file that more or less let Python detect all the static typings or all the static types that your program uses. It generates a C file, and then it compiles this C file with a compiler. So more or less, you can, after running Python on hello world, you can just execute it. It will create a nice binary, and it will be super fast. This strategy, by the way, is how PyPy is implemented, which is super smart, because PyPy is implemented in Python, which can be both executed in Python and in Python. Basically, like it's a subset. So that's awesome. But there was one issue. Dictionaries could be dynamic. So if you see, like in JavaScript, like you can have the dictionaries with multiple keys and multiple values or different types per value. In Python, it didn't let use basically like different keys for different values. So it was challenging to get, actually at the beginning, my graphical Python library to compiling into native. Then next one, Codon, was launched about 1.5 years ago. Codon analyzes your Python code. It generates an abstract syntax tree from Python. It runs a type checker, trying to detect like what are all the types that basically your programming is having. Then it compiles into LLVMIR, basically like intermediate representation format. From that, it does some optimizations. And then it goes into target. So this is great, but there were many incompatibilities with Python. It did not support basically like subtyping or meta classes. There are like certain things that they are working on. And actually, I chatted with the founders. They are working pretty hard to make this happen, but they are not yet there. They will get there, though. So I'm pretty excited about this path. The cool thing is you can get like super fast speeds if you compile Python to LLVMIR and then to WebAssembly this way, more or less like 3 to 10 times faster, which is great. Next strategy is using Python JITs. So basically compiling the hot paths that your program is running to then like generate basically like assembly code that can run like at super fast speeds. So what are the pros is you will get pretty fast speeds, but there are two cons. First one, that it needs to warm up, which is not really ideal. And the second one is, even though JITs in WebAssembly are possible, are not trivial to implement. So the JavaScript equivalent here on the runtimes are V8, JavaScript Core, or SpiderMonkey. So here I'm going to show like very quickly a demo of running like Py-to-Wasm, which, by the way, this project is being here for 4 years already. We are not creating anything new. So what this is doing is using PyPy to generate JavaScript code that more or less like it's on the hot path. So basically, it compiles the hot paths of Python into JavaScript and then uses them. So let me just kind of like quickly show a demo. Py-to-Wasm. This, by the way, you can check on Google. It's awesome. So this, you can do whatever you want. It's a normal Python equals 2, or like you can do. One second. So it's super fast. It's really, really great. And actually, it's very fun to see how this was working. This made me realize that having JITs in WebAssembly was fully possible. This, by the way, is actually not using as a WebAssembly. This is using asm.js because it was created 4 or 5 years ago. So let's go back to the slides if I can see them. Here we go. So on this quest, I would recommend, if you're interested on like how JITs on WebAssembly work, I'd recommend you assisting like the talk from Dimitri, basically like mentioning that he's going to cover like how JITs can work on WebAssembly with SpiderMonkey, which is super interesting because, yeah, I think it will enable like many paths for running JavaScript in WebAssembly performantly. What's the issue with this? Is that by like running JITs on WebAssembly, it's possible, but it gets more time to get right. Basically, you need to make sure that the WebAssembly code that you're generating is performant enough, that basically you need to spend more time. This is a great path. I think it's pretty strong one, but we're a small startup. We need to go into the cheap fast first. So next strategy, static analysis. With static analysis, basically what we can do is build performant code based on the types that your program is using. So if you know MyPy is a static Python checker that basically like checks that like all the Python code that you have is basically like the type checked and it's using the right types and so on. And they have a MyPy-C that more or less like creates C code from your MyPy code or Python code. And then there is Nuitka. And Nuitka is a Python to kind of like C compiler. We'll see this in detail in the next slide, so don't worry, I will cover them in detail. So with this strategy, we can get like our code is going to be mostly compatible with Python, so we don't need to do any adaptations from our code. We can just use the normal Python code that we use. It will only get from 1.5 to 3 times faster. So it will not be as fast as the other strategies. And it's very complex to get right. Basically, like, and this is not on the path of basically whoever is writing the Python program is in the path of whoever is creating Nuitka or MyPy-C. This is not easy, and there may be like some weird quirks. And also, this implies very large binaries. Why? Because you are compiling your Python code or transforming your Python code into C code, and basically you are injecting this into the WebAssembly. So it's going to get into larger binaries. So MyPy-C, it's basically an extension into MyPy that actually can compile MyPy itself, which is super cool. I'd say we can call it self-hosting. And basically like this, what MyPy-C does is detects all the types, generates C code, and then it's trying to basically like compile it with C or with a compiler. It has, let me go back. It has some issues though. The main issue is that when using MyPy-C, it will generate basically like more or less like dynamic libraries to then like being able to load them at runtime, and dynamic libraries are not yet supported in libc. Although it's fully possible. It's fully possible. It should not take very long to do that for whoever wants to work on it. So the next strategy is Nuitka. Basically, like Nuitka is a Python to CPython transpiler. So basically, it analyzes your code, and it calls the underlying CPython calls that makes that happen. So more or less, it gets rid of the interpreter. It supports most of the private programs. It transpiles Python code into the corresponding CPython codes, and it can even work as a code obfuscator. So let's say you're working on something proprietary on Python, and you don't want anyone else to see your source code. You will be able to more or less obfuscate it with this. Again, it's WebAssembly, so you can always inspect how it works, but it will be hard to really understand it. Are there buts? No, there are not. I think this was our most viable strategy. So let's try to see if we can make this work. So I'm going to do a demo of how Nuitka works, just so you can see. So I'm going to go, not this terminal, cool. So let me show you basically like a program that I have like running locally, which is Python. This can be, oops, sorry, not this program. So this program is a normal Python program. I have not done any modifications whatsoever of this program. So I mean, you can check, it's doing like all the things that like we expect from Python working. And basically like what I can do is I have obviously installed Nuitka, and I'm gonna basically like compile this python.py to basically like native Python code. Gonna run this. This, for the first time, if you run this in your laptop, it will take like a little bit more time. By the way, these things is because I was debugging just right before the presentation because certain things were not working. Everything is working again, so happy about that. But basically, like you can see that this command that I run, it generated like a binary. So let me check what's this binary type. So we can see it's a ARM64 binary. So let's see if I can get this running. Cool. By the way, this is debug information. You should not see that. But basically, we can see that like running this with Nuitka is actually super fast. And if I run this natively with my laptop, which is this, it will get like into a little bit like less performance. Cool news is, well, you will see in a bit. At the end, the cool thing is no matter if you're using libraries or anything, everything will be working with Nuitka. So let's go back into the presentation. So the main question here is, will this compile to Wasm? If Nuitka generates C code and uses a compiler, can we just switch the compiler? What you guess will be the answer is no. So basically, like one does not simply compile to Wasm. In the case of trying to compile Nuitka to Wasm, basically, like I realized that the latest Python was not compatible with Nuitka. The main reason for that is if you have been following the progress on Python, Python have been doing a lot of improvements into the interpreter to improve the speed. And as part of that, they have done like a lot of breaking changes on strings and other things under the hood. So basically, Nuitka have to catch up a little bit. And the other issue is it doesn't support cross-compiling to different architectures. So basically, like normally when you run Python, you're in 64 bits, and you have to compile to 32 bits. So I'm going to tell like a little bit fun story. I got the prototype of this working 4 years ago. The only thing is we have like other things to work on, so I didn't focus on this again. When I submitted the talk, I assumed everything was going to work as it did like 4 years ago, and it was not that way. And this, basically at the beginning of this week, I realized that there were some challenges that I was not expecting. The cool thing is we actually got it working. So today we are announcing Py-to-Wasm, which is a Python to WebAssembly compiler. It's great. It's using Nuitka. We have done like a small amendments that will be merged upstream at some moment, hopefully like not very far from now. And yeah, basically like how this works. You just need to install like Py-to-Wasm and then run it locally. There are certain challenges that we are seeing right now, but this is the flow that we want to work. And the challenges is basically Python doesn't include certain files by default that we need it to be included. But don't worry, this will be fully working basically like when you have the time to do it on your laptop. So how fast we can get? So in general, like let's say you want to run Python in your laptop with Python or with Wasmer, basically like inside of the CPython interpreter, you can get into 89,000 Pythons per second. And when basically compiling this natively, you can get into 3 times that speed, which is not bad. It's still like a little bit slower than native, but I'm pretty confident that we can get almost up to native speed. When I tried this 4 years ago, actually I got running through WebAssembly faster than running natively. So I think it's, there are like certain optimization things that we can do. Right now we have not done them yet, but like I think it'll be very, very possible. So not plan ahead yet. So I'm gonna do a live demo just so you trust me that this is actually like working. So here we have the Py-to-Wasm. Okay, there are certain challenges here. Oh, okay. Wait a second. I might have fucked up something just before. Oh, here we go. Cool. Perfect. So basically, like when running, I'm gonna demonstrate like running Python like normally, like natively with Python. It will get like 13 Pythons. And what I can do is, and I'm hoping, I just ran it before and I thought I got it working. So, okay. I mean, we're getting like one last error, but like this shall be fully working. This is the like demo time because I was doing a lot of refactors to have like the library published, but this is fully working. You just need to trust me. Hopefully, like the trust gap will not be like super big. So let me go back to the slides, and we'll see what's lying ahead. So what's lying ahead for us? On one front, we want to compile our Wasmer Django backend into WebAssembly via Py-to-Wasm. Cool thing is we don't need to do any modifications whatsoever for our code. Basically, by using Py-to-Wasm, we will be able to run our backend at 3x the speed that we used to run them. The other thing is, for compatibility reasons, I actually decided to use WASI instead of WASIX, just because it was going to be easier for other people to try and ignite runtimes and so on. But the issue on WASI when targeting Python is that you don't get support for threads, you don't get async IO, sockets are not supported. Basically, there are like many issues. So we want to use WASIX to fix that, or to bypass the issues that we are seeing. And we want to get Py-to-Wasm running fully inside of Wasmer. So basically, you can imagine just doing like Wasmer run Py-to-Wasm. This is a package that will be published into Wasmer. Just provide like my file.py, not .app. That was a typo on my end. And then get a WebAssembly file output. And you might think, what do you need to do to get this working? Actually, we'll need to get Clang fully running inside of WebAssembly. Stay tuned for updates on this front. Things are going to get very interesting next months. So upcoming blog posts will be coming pretty soon. You can stay tuned on wasmer.io, follow Wasmer in Twitter. Just kind of like stay tuned. I think you might hear of this pretty soon. And that's it. Thank you. You can follow Wasmer on Twitter or on GitHub, or follow me, or follow anyone in the team. And that's it. Thank you, everyone. And now it's time for the fun part, questions.
Thank you. Excellent talk.
Thank you.
I have a couple questions. One is, have you tried running the Wasm in another runtime besides Wasmer?
Yeah, it's fully WASI compatible, so yes, and it works.
OK. Second question, how do we deal with native dependencies of Python?
Nuitka handles that. OK. Dependencies, Nuitka handles that like brilliantly. Native dependencies, basically like normally like native dependencies in Python are a little bit challenging, right? Okay. So basically what you need to do, there are 2 things that we need to have native dependencies fully working on Python. On one front is support for DLOpen, DLSim, and so on, basically fully working. This, by the way, is fully doable. Like more or less in a week of work, you can get this running. It's not challenging. So that's one thing that you will need to do. And probably like we are going to add this for supporting WASIX, so like that's kind of like that will get like fully running like native modules like NumPy, Pandas, and any other like Python libraries that are using C under the hood. And yeah, that's it. Basically compile your libraries into WebAssembly and then load them via, or WASI, and then load them via dlopen as long as dlopen is implemented in libc, which should be soon, at least on WAS6.
Thank you.
More questions? I chat about many things. Hopefully, JITs will be interesting for you. But if you have any questions, we are going to be on the Wasmer booth. Feel free to come, and I will do like the demo properly working. I'm apologizing for the last demo moments or the demo gods. I have not prayed to them before the talk. So yeah, thank you very much, and really thank for everyone to attend this talk. And yeah, I hope to talk with you later. Thank you.